Hello guys, welcome to this video. So in continuation, we'll discuss the propagation of errors in multiplication in this video, and in the next video we'll discuss the propagation of errors in division operations. But let's dive into multiplication. So for multiplication, let's assume we have a quantity x plus or minus delta x. That's its approximate error, and we have y plus or minus delta y as its approximate error. So where delta x and delta y are absolute errors, then x and y are the measured values. So what is going to be the answer when I multiply x plus delta x and y plus or minus delta y? So what would be the answer? I'll assume that the answer is z plus or minus delta z. Is that okay? So I'm going to expand the right hand side. Expanding the right hand side, I'm going to have x, y, and I'll now have plus or minus y delta x. Then when I do this and this, then when I do this and this, I'll have plus or minus x delta y. Then when I do this and this, I'm going to have plus or minus delta x, and let me see, delta y. Now you need to know that this absolute error is very small. So since the absolute error is very small, delta x and delta y are very small. So this product, delta x, delta y, is going to gradually tend to 0. So we can neglect it. Is that okay? So since we can neglect it, then you're not going to have x, y. So I have, since this place has a plus or minus and a plus or minus, we can just summarize it to plus or minus y delta x and plus x delta y. Is that okay? So this is my z plus or minus delta z. So we can now see the two sides, that z corresponds with this guy over here. So z is equal to xy in this case. Then this over here, as you can see, is my the approximate error, the absolute error in the measurement of the product, and delta z is equal to y delta x plus x delta y. So in fact, delta z, since it's actually an absolute value, it will be wise if we represent it with this particular symbol, that delta z is equal to y, the absolute value of y delta x plus the absolute value of x delta y. So we've gotten what we are interested in. Z is equal to this and delta z is equal to this. So these are the two quantities you'll be asked to find whenever you're given problems that has to do with multiplication. So find the measured value and find the associated absolute errors or relative errors involved. Now to solve this problem, we don't just stop at delta z, which is our formula for absolute error. We take it a step further by determining the relative error. And how can we do that? To determine the relative error, what do we need to do? Of course, you need to this relative error, if you can remember in one of the videos that I posted before this one, I defined relative error for precision. And relative error for precision is given by the absolute value divided by the original measured value over here. So there are two types of relative error. Please, if you need information about that, check the video that I have posted on relative error, absolute error, and precision and accuracy. You're going to see the full explanation. So if I divide this by z, I'm going to get relative error. Is that okay? Precision, relative error. And this also applies on the right hand side. Plus x delta y divided by z. Now watch how I progress from this point. Is equal to, so I have y delta x plus x delta y. Is that okay? All over z is xy. Now check this out. There is a property in absolute value called subadditivity. So we have subadd. So the subadditivity property of absolute values is that whenever I have an absolute value of a plus b, the answer is still the same thing as you having the absolute value of A plus absolute value of B, like this. So the absolute value of A plus B is less or equal to the absolute value of A plus the absolute value of B. So you can actually prove this with some let me see, numerical approaches by substituting for different values of A and B, and you get the subadditivity property. I'm going to apply this subadditivity to the numerator of this equation over here, and I'm going to get that delta z over z is less or equal to, I have y delta x modulus y delta x plus modulus x delta y, then all over xy. So if I distribute the denominator, delta z over z is less or equal to, we have y delta x over xy, then we now have plus x delta y over xy. So basically you can see that this is still the same thing as, it's still less or equal to y delta x, okay, over still xy. Xy is still the same thing as magnitude of xy since it's positive, delta y over xy. So under this condition we can actually say that ka over, let me say, kb is still the same thing as modulus ka over kb. So we can actually maintain the division in divisibility in absolute value signs. We can go from here to here, and we can go from here to here. It's still the same thing. I can cancel k from here, or I can cancel k from here. In the same vein, I'll cancel out x from here, and I'll cancel out y from here. So what I'll be left with is delta z over z is less or equal to, I have modulus x over x plus modulus y over y, like this, which is still the same thing as you having less or equal to modulus x over x plus modulus y over y. Is that okay? So this is what happens when we are dealing with multiplication. This is what we call relative error. So if I want to qualify it, I'm going to add precision relative error. So this is precision relative error. Okay, please take note, you're going to need it. So why do we need the precision relative error? Because anytime you're given a problem that is involving multiplication, let's say a z plus or minus delta y, z plus or minus delta z is given to me as x plus or minus delta x times y plus or minus delta y. They'll give me x and its associated error, y and its associated error, and they'll ask me to determine what z is and its associated error. So all I just need to know is that z plus or minus delta z is still going to be what? My xy plus or minus absolute error. Okay, absolute error. So what is the absolute error? The absolute error can be gotten from this place. Okay, you can get the absolute error from this place. So to get the absolute error, all you just need to know is that absolute error divided by actual value, or divided by measured value, okay, is equal to relative error. In this case, I have my precision relative error. So when you divide absolute error absolute error by the measured value, you get your precision relative error. In other words, your absolute error is still the same thing as you saying the relative error, the precision relative error multiplied by the measured value. Is that okay? So this is what is going to give me the absolute value that I'm going to put here eventually, and I'm now going to use this to solve for z, because they want me to find z and delta z. So delta z is your absolute error, and remember, you can get your absolute error from your relative error. We've already gotten the expression for your relative error here. Your precision relative error, just divide the the absolute value of x by the size of x divided by the absolute value of y and the size of y. Just divide it. Okay, so there are other precise way of expressing this. Some people might actually use a standard deviation approach, but this one is also acceptable mathematically. So we'll not dive into the standard deviation part, where we'll be saying our delta z over z is actually equal to the square root of delta x over x all squared plus delta y over y all squared. So that one is actually more complex and advanced for our level now. Maybe in a higher level we'll get to understand the standard deviation aspect of the relative error, but this one is actually acceptable. It can still give us the same accuracy as the standard deviation will give us. So after getting relative error, don't forget to get your absolute error by multiplying the relative error, which is delta x over x plus delta y over y. Multiply it by the measured value. The measured value is simply xy. Okay, xy is the measured value. In other words, the measured value is z itself. So this is going to give me an expression for determining z and the associated absolute value when I'm multiplying two quantities x and y, such that the absolute values are given to me in this way. Now there's something else you should know. This multiplication is not just restricted to two quantities. It can be three quantities, 4 or 5. So the underlying methodology will still hold, in the sense that to get the measured value, all the measured values from the quantities contributing, they will multiply themselves, and their absolute values or their individual relative or precision relative values. For x we have delta x over x, and for y we have delta y over y. So their individual precision relative values will be added to give you the final relative value. Then to get the absolute error, multiply the total relative error by the measured value, which is the product of all the quantities. And finally you should house the expression in this way. House the expression such that your z plus or minus delta z is equal to multiplication of all magnitudes, okay, involved, plus or minus absolute error. And the absolute error is simply sum of individual relative error times measured value. So this should give us don't worry, we are going to solve an example, but till then stay tuned for the next video, which is the derivation for division, and we are going to learn how to errors propagate when we divide quantities. And stay tuned, like, subscribe, share, hit the notification bell. If there's any question, leave it in the comment section and I'll be happy to attend to you. Okay, I'm signing out now.